In this example, we're going to use technology to find the following if k of x is equal to negative 1/3 x squared minus 1.2x plus 5.4. All right, so since it says using technology, we're going to go to Desmos and we're going to graph this function that we're given, k of x, and we're going to be looking for the vertex, the intercepts, domain and range, k of -4, and we're also being asked to solve k of x equals 2, k of x greater than 2, k of x less than or equal to 2. So we're curious about when the output is 2 as well. Okay, so with those things in mind, let's go to Desmos and graph this. So we're going to graph this function, k of x equal to negative 1/3 x squared minus 1.2x plus 5.4. Okay, so it's graphed it for us here. There are some key points that it's highlighted here. I'll highlight those more firmly in a minute. But we want to know all of those, right? The vertex, the intercepts, and so on and so forth. The other thing that the problem asked, I remember while we're here in Desmos, it asked for k of -4. If you just enter, once you define the function as k of x, if you just enter k of -4, it will give that to you, whatever that is. The other thing that we were asked for is to solve things like k of x equal to 2, k of x less than 2, things like that. So I want to graph y equal to 2. And it'll just graph it straight in there so I can get a sense of where those intersections are. Okay, so let's make sure we've got all the points that we need. I want the intersections between those two. I also want the intercepts, right? X and Y intercepts. I want to make sure I highlight those. And also the vertex, right? All right, so based on the information that we just learned in Desmos, we know that the vertex is -1.8, 6.48, right? Just taking it right off of the graph. So the vertex is the maximum point there, okay? And the y-intercept, where does it cross the y-axis? 0, 5.4, okay? And what are the x-intercepts? -6.2090. And what's the other one? 2.6090? I'm out of room there, huh? Okay, and what is the domain? So the domain of a quadratic function is all real numbers unless it's in context and there's something that might limit that domain. So in this case, we're going to say the domain of k is -infinity to infinity. Now the range of k is the set of all possible y values, okay? That does have some limitation with a parabola, right? The largest y value that this function carries is the 6.48, right? So the range would be -infinity up to 6.48, and we would be including that, right? Okay. That is including the 6.48. Don't include -infinity, right? You can't get there. But we have a nice solid dot, and the 6.48 is included on the graph. Okay, and then it says calculate k of -4. With technology, we're told that k of -4 is equal to 4.86 repeating, right? And of course you can plug the -4 in there for x and see if you get the same value, but Desmos is telling us that that's what it is. Okay, then it says solve k of x equal to 2. Okay, so remember that when k of x is equal to 2, we're saying that the output is 2, right? So that's why I put a line in there at y equal to 2. So at the intersection points, notice that the y value of the function is 2, right? We want to know the x values that make that statement true. So what are the x values there? I'm just going to state them in a solution set here. -5.466, and what's the other intersection? 1.86. Okay, so you're taking the x values of those intersection points where the parabola intersects the line y equal to 2. Okay, then it says solve k of x greater than 2. Okay, so when we say greater than 2, we're talking about where is the graph of k of x above the line y equal to 2. All right, so I'm going to highlight where that happens. I'm going to put a little open dot at those intersection points in green there. Where does this graph lie above that horizontal line of y equal to 2? Right there on that green piece that I shaded. So what is the domain of that green piece that I shaded? Because the domain of that includes all of the x values that make that statement true, k of x greater than 2. So I would say, well, between negative 5.466 and 1.866. Right? And I'm using, that's an interval, and I'm using an open bracket interval because I have k of x strictly greater than 2. Okay, then it says solve k of x less than or equal to 2. Okay, so now we want to know where are the y values on the parabola less than y equal to 2, right? So in other words, where does the graph lie below that horizontal line at y equal to 2? Okay, so in this case, I have less than or equal to, so now it's a solid dot, right? And I'm going to shade the stuff that lies below that line, okay? All right, and so what's the domain of that purple piece that I just shaded? Negative infinity up to negative 5.466, close bracket, right? In union with positive 1.866 to positive infinity, right? So again, I'm taking the domain of that purple piece, right? Everything from negative infinity up to that intersection point with y equal to 2, and then the intersection point on the other side to positive infinity, yeah. Okay, so now, just a reminder about this. I always like to actually look at the graph and write all over it to show you what that means. But Desmos does this great thing where it'll just do this for you. So let's take a look. Okay, so for a moment, I just want to look at the graph of the parabola and that line y equal to 2 and notice some things. So if I actually enter in that inequality, if I say k of x greater than 2, notice that it shades that, all the stuff between those two intersection points, right? And that's what we said that the solution would be, and it's got dashed lines there, right? So we're not including the x values of the intersection points. Okay, and what if I said less than or equal to? We have a less than or equal to sign. Yeah. Okay, so now what did it do? It shaded the two extremes, right? Everything less than that first intersection point and everything greater than the second one, right? So that's consistent with what we were looking at, just thinking about where does this graph lie above the line y equal to? Where does it lie below that line? Okay, so I just want you to notice that the computer will give that to you very, very easily, but I also want you to understand graphically what's happening there and why that solution is what it is.